all we can see from Jupiter is the outer part of it, top of the clouds. We know there's clouds in the upper atmosphere, but there's stuff inside of Jupiter. So the interior of Jupiter, as best we can tell from the spacecraft orbiting, is, as I said before, a solid-ish core. They still are debating whether it's really solid or perhaps molten or partially molten. And then a thin layer of liquid ices. Even if water is a major component of that, it is under such high temperature and high pressure, it does not even resemble the substance that you know of as water. Certainly, it may be liquid, but it is not going to be a common liquid as you know it. There's actually different states of liquid here, and this is going to be something that you've never experienced or has never been experienced on Earth. The conditions, the temperature, and the pressure here is phenomenal and virtually impossible to reproduce on Earth even. And so all we can do is theoretically state what it should be. We have the layer, a huge mantle that's mostly liquid hydrogen and helium, but it's liquid metallic hydrogen. Okay, so the liquid metallic hydrogen, and then the outermost part is ordinary hydrogen and helium. At the upper level, it's gaseous. At the lower level, it's liquid. And then below that, we compress and heat up the hydrogen so that it becomes metallic. So the mantle is actually electrically conducting, kind of like the outer core of the Earth, except instead of being iron nickel, it's actually hydrogen that's doing that, metallic hydrogen. There is no surface. Okay. So as you go deeper and deeper into it, at some point the liquid metallic hydrogen is going to be so dense and so forth that the transition there is between that and the solid is going to be very difficult to really parse out. The other thing here is that you'd sort of think, well, we've got this layer of liquid hydrogen down deeper because you're squeezing it into a liquid, and so you might think of it like giant ocean of hydrogen, and you think of like it's the surface of the ocean on Earth. That's not at all the way it is in Jupiter. There's not even an ocean surface here, because the temperature and pressure inside of Jupiter exceed the critical point for hydrogen. Now, in chemistry, if you make a graph of temperature and pressure, there's a spot here that you can say, well, if you're on this part of the graph, it's solid. On that part of the graph, it's liquid. On this part of the graph, it's a gas. But at some point, there's a place called the critical point. Okay, beyond that critical point, it becomes impossible to distinguish really between liquid and gas. They're both a fluid. It flows, so both liquid and gas will flow, but you can't really say it's just liquid or just gas. And so that's kind of what is happening inside Jupiter. As you get to the upper part of Jupiter's atmosphere, it is most definitely gaseous hydrogen and gaseous helium. As you get to the lowest part of the atmosphere, then the pressure is so great you've actually squeezed the hydrogen into a liquid. So it's definitely liquid hydrogen. But in between, you have this area it's neither liquid nor gas. It's got kind of properties of both. And so it's like, you get higher and higher, it's more gassy, get lower and lower, it's more liquidy, but there's not really a boundary between liquid and gas. And, like I said, bottom of the atmosphere, you pretty much would say, oh yeah, that's definitely pretty much liquid hydrogen. Top of the atmosphere, you say, yeah, that's pretty much definitely gaseous hydrogen, but in between, it doesn't behave as either. It's just a fluid. Okay, it behaves as both and neither. And so this is what we mean by critical point. So you just gradually go deeper and deeper into it, and you gradually make this transition from gas to liquid, and it's not like a sharp dividing line. So there actually is no ocean surface either. Jupiter simply has no surface. Okay, that's why we often use the layer of the clouds to indicate the size of the planet. Juno indicates the core is probably a bit larger than previous spacecraft indicated. It may be about 10 to 30 times the mass of the Earth. Now remember, Jupiter itself is much, much larger than that. So most of the mass is still hydrogen and helium. The core is squeezed down to the size of Earth. So even though it's 10 to 30 times the mass of Earth, it's squeezed down to the size of the Earth. Okay, and again, as I said before, it's not entirely clear whether that core is solid, as we know solid, or if it's some other fluid state, whether that fluid state be liquid or something else. But definitely the temperature and pressure in the center of Jupiter is not like anything that we can reproduce on Earth at all. So we just give our best guess as to what the core is really like, even if we knew what it was made of, which we don't really even know what it's made out of exactly. We just guess at the conditions, under the conditions that it's under, what sort of state it might be in. The liquid metallic hydrogen region extends from near the core about 80% of the way to the cloud tops. So much of the planet, most of the planet, in fact, is liquid metallic hydrogen. Now, remember I said that it has a huge magnetic field. This is where that magnetic field is coming from. Not the core, but this giant liquid metallic hydrogen mantle. That's making the magnetic field. And it rotates much, much faster than Earth does, and therefore it's going to have a much, much stronger magnetic field. That and the fact that the region making the magnetic field is vastly bigger. It's the bulk of the planet, in fact, is this liquid metallic hydrogen region. And so that makes Jupiter quite a bit different than any world that we've studied so far this semester.